Sampreet, we are going live. Okay, hello everyone, and welcome for the third interview in our ongoing live interview series, which has been titled as Technology in Architecture and Design 2.0. The focus of today's talk is the discipline of structure and the larger practice of structural engineering. And I would like to begin today's discussion with a very famous quote by Sir Darcy Thompson in his seminal book, which is called On Growth and Form. So he proclaims, that form is a diagram of forces, and many of us architects, engineers who have cherished the works of many of the structural engineers, the likes of Nervi, the bridges by Robert Maillard, the shells by Felix Candela and Friotto, Gaudi, Ilario Dieste, we can very easily connect to this statement. And when we think of it, it comes to our mind that the practice of structural engineering is not just about calculations or just about getting certain objectives on the paper, but there is a larger subjective aspect attached to it as well. And hence, it is not only a professional practice, but it is equally a design discipline, which involves the structural intuition as part of the discipline. So we last year, when we did our first round of this particular series, we had an opportunity to talk to Professor Gurdev. We also had an interview with B.L. Manjunath from Bangalore, and we had a fantastic conversations on this particular theme. I'm really glad to share that to take this discussion forward, today we have with us Professor V R Shah on board. Sir, thank you for joining on ArchiDiaries.
My pleasure.
And so the format of today's interview is going to be slightly different. We are not, our regular format is that we make a 30-40 minute presentation and then we have a short discussion on the basis of that. But here we are going to make this a kind of a panel discussion, and Professor V R Shah is going to share his experiences of being involved in the field of practice, academics, and also advocacy and research. And in order to generate that discussion, I'm really glad to share that we have Professor Bhairav Patel with us as a panelist. So Bhairav, thank you for joining with us.
Thank you.
So thank you, Bhairav. Before I hand it over to Bhairav to sort of initiate the discussion, please allow me to introduce Professor V R Shah and also Professor Bhairav Patel. Professor V R Shah is an academician and practicing structural engineer. He is founder and principal structural designer at Vinod Shah Consulting Engineers Private Limited, a firm engaged in design of structures. He has taught at CEPT University for almost 33 years, where he was engaged in teaching structure to architects, engineers, and designers. He also headed the PG course in structural design, a course unique in nature as it was for educating engineers to become designers. He has offered workshops on structure for students of architecture in many universities and also presented papers on diverse topics related to structures across the globe. His present interests are seismic design of buildings and teaching methodology for architecture students. Currently, he is also involved in teaching structure as a visiting faculty at CEPT University, Nirma University, and Navarachna University. Please allow me to introduce Professor Bhairav Patel. Bhairav Patel has an experience of more than 13 years in the profession of structural engineering and has worked on structural design of a variety of projects. He has a bachelor's degree in civil engineering from Nirma Institute of Technology and a master's degree in structural design from CEPT University. Bhairav Patel started his own private practice in the year 2012. Since then, he has worked on a variety of projects involving different materials like glue-lem timber, rammed earth, bamboo, masonry, etc., along with conventional concrete and steel structures. He's also fond of teaching and has been involved as a visiting faculty at CEPT University, Ahmedabad since 2009. I'm really looking forward to the discussion here between Professor VR Shah and Professor Bhairav Patel. I think I would like to invite Bhairav to sort of take it on from this particular point.
Sure. Thanks, Vyas, for the introduction. Yeah, I know Professor VR Shah since a long time, earlier as a student and later on as a professional, as a colleague, as a mentor. It has been a long association with him, and I have always wondered that he is qualified as an engineer, but he has probably spent more time with architects because of his association with the School of Architecture since many years. And generally, under such circumstances, it changes an engineer into almost an architect. But that has not happened because he was also very closely associated with practice, and he has designed, he was once telling me that he has designed more than 200, 300 projects over the course of his career. So I'm sure it has been an interesting push and pull from both the disciplines, and trying to manage both the aspects of it. And that brings me to to the starting point of this discussion, where what is the difference between the thought process of an engineer and an architect? Because they say that men are from Mars and women are from Venus, and it would not be totally inappropriate to say that both architects and engineers also, it seems, belongs to different planets or different worlds. There is definitely a lot of difference in the education, in the thought process, in the way they think, in the way they approach practice. And I think I would like to, because he is associated with both the disciplines very throughout long career of his, I would like to know of his opinion that how these thought processes are different, and how can one evolve to, because there is a constant need for dealing between the two, because although they may belong to different worlds, different thought processes, they have to work together, right? So how do they bridge this gap? So I think we can, I would like to get his opinion on this.
Yeah, Bhairav, it's a very interesting, and at the same time, it is the question that I keep asking all the time. When I started my career, I was asked to teach the structures, and I still remember that I got a very heavy resistance from the students. They were not ready to, learn structures, and then I had to do, a lot of work to make sure that this starts becoming accepted to them. And over a period of time, I worked further into it. But I think to answer your question, I'll say one story. I like telling stories. So go to that first PPT's image.
Just give me a second.
Yeah, I think it is, in the meantime, I can keep talking, is that it is the structure that many of those who are around Ahmedabad and those who have visited Ahmedabad, they know. This is the structure by Asmukh Bhai Patel, architect. It's a Patang building.
Okay, so my screen is visible?
It's visible. Go next. Next. I'll come to this. Next. Yeah. Let's see. If you see this building, this is the conversation between Asmukh Patel and engineer Mahendra Mehta. Mahendra Mehta is having his PhD from US, and he was contemporary of Fazlur R Khan, a brilliant engineer. So, but he was a jovial person actually. So he's still alive. I'm talking about the past. He and Hasmukh Bhai were talking about. And if you see in the picture, there is a slit there. Actually, Hasmukh Bhai wanted that slit to be continuous, without those, interim members. So in his own style and mood, he said that, Mahendra Mehta, look at this, how dull and boring you are. You provide these kind of intermediate members. And can you imagine? You don't have that, power to imagine. Just imagine a lift is passing from bottom to top and you can see the whole panoramic view of river. In those days, of course, the river was dry. But today, you can see that. You can see the whole panoramic view and you're talking about these intermediate beams. And Dr. Mehta responded very well. He laughed. And I think it was, I've seen that when he and Dr. Vakil went there together into their cabin and when they laughed, you can hear in the next room also. So he laughed and he said, first I'll say this in Gujarati and then I'll translate it in English. Hasmukh Bhai, ubo rehse to dekhas. The translation is that everything that you're talking about is possible if it stands. So this actually is the major aspect, that the responsibility of the structural engineer and what architects wants to see. That's a major difference. Now let's go back to the earlier. I think then when Bhairav asked me this question, actually it starts with go back to the first slide. Yeah, next. See that all of us know that structure has always been an inseparable and integral part of the architecture. So we need to understand the relationship between structural engineer and architect, relationship between structure and architecture. So that's the question that Bhairav has asked. So let's go to the next. I talked about this. Okay. So if you want to understand that, we need to understand that how the profession of architecture and engineering is different in terms of academics, in terms of practice, in terms of the education, and in terms of the practice. Actually, if you look at it, when the whole thing started, actually, when people were building, there was no difference between one who will build and who will conceive. So this whole thing, schism, actually started when it was possible that somebody will conceive and somebody can construct. So there are two parties into that. So then this whole thing about that I need to conceive something and there is somebody who will execute or who will construct. So then this earlier it was that the person who was conceiving, he had a fairly good idea that how will he construct it, how will he get the material, what kind of material from where, etc., etc. And we sometimes use the word master builder. So that was the thing. But when this started, there was a specialization. And specialization went into the extreme, there where those who were conceiving, they thought that they can do anything, and the engineers were ready that they were also ready to take the challenge and they will build. But then the question is, was there any reconciliation? Yes. There are some examples where you can see there people, meaning architect and engineer, they work together. They collaborate. Now, and there are excellent examples, where you can see this collaboration. Like if I talk about outside, it is okay, but even in India, if you talk about Mr. Mahendra Raj, a great structural engineer, so he used to collaborate with the architect, and sometimes, his own involvement into this and the kind of, creative suggestion that he can give, whole design used to change. And I think those who are interested, that they should read his book. And there are a number of videos that also you can see onto the web, that his creative input and how the architectural design has changed. So that is one. Go to the next. Yeah, so this is what that was a master build, that before Enlightenment and Industrial Revolution, it was difficult to distinguish between architect and engineer. Next. Yeah. Now this is a little bit about structure and architecture. That is, there is two extreme where on one hand what Ayaz, started when he was talking about people like Pierre Luginarvi and other people. So where the structure itself is an architecture. So engineer determines the form based on structural efficiency and technology, and the aesthetics is a result of the same. You don't have to think them, you don't have to think them separately. So it was outcome of the structural configuration, material, form, etc. Next. So if you look at these, structures, they were all structures by engineers, but there is inherently you can see that structure itself is an art. Yes, next. Yeah, and there are you can in between you can put a lot of things where these things have happened, but extreme is structure ignored completely. Architect determines the form from the consideration of aesthetics, ignoring the aspect of structure and technology. An engineer is concerned with safety and safety of the structure only. So that's the extreme, But what we do, what Bhairav is also trying to do, and other, the sensible structural engineers who are sensitive to the architecture and aesthetics. So they do a good collaboration with the architects. So that is one example I have shown next. This is structure ignored, completely. That Ujjon wanted that to be some from the natural object, but it was completely ignored in the process. Next. Architect-engineer collaboration. This is what we are interested and what we are trying to do in our practice, and many other sensitive engineers are also trying to do this, is both work together and design is evolved jointly. So next is actually, these are some of the structures. This is Waterloo Station. Actually, the whole geometry and the form and the structure has come from 3-hinge arch, and it is expressed here. There are a couple of other pictures and I'm not going into the detail, but those who are interested, they should go. Actually, it also follows the structural actions, where the tension is, where the compression is, and all those things have come into that. Yes. Next. Yeah. So I was talking about Mahendra Raj. Here is a picture. Actually, in those days, he had done this, and he actually had given space frame in the concrete in those days. Next. Yeah. And this is what I was talking about. This indoor sports stadium actually is what I was talking about. It is the Mahendra Raj was the structural engineer, and Mr. Kanvinde was architect, and he actually wanted this kind of a thing in which actually he was ready to give the internal columns. But then Mr. Mahendra Raj said that no, without that column also I can give you a form. And I don't know, those who are, those who can see the similarity between the two, it's more or less the form is same. But in the earlier case, it was a space frame. In this case, he made the whole thing in bending with pre-stressed concrete. And these are last part. But then he gave this thing without column. And then Mr. Kanvinde said that I'll change my design. And he changed the whole design. So this is the kind of collaboration that is possible if architect and engineer both work together and they are ready to understand concept and the requirements of each of them. Next, I think that must be the last one for this first. Yeah. Just check.
Yes. Yeah.
Right. So I think partly I have answered your question. The only thing that was not covered, maybe I'll be covering that later, is that about teaching this, to the both structural engineer as well as the architect. So let me not finish everything in only one question. That we will come to that in the later. Yeah.
I have observed that generally architects would complain that engineers are not creative enough, or not willing to explore different things, whereas engineers complain that architect is not understanding a very simple requirement, that this is how it works. So there's also a friction in that. And since you have worked with so many architects over a period of time, and you have also taught architects, how do you think we can bridge this gap? I mean, should an architect take the lead in collaboration? Should involve engineers earlier, or should engineers come forward and take a stand that I mean, how do we bridge that gap, or how those people like Mahendra Raj have bridged those gaps? And what is your own experience while working with so many architects?
Yeah, actually, this whole question is in a way very large, question, because the first and foremost is the two professions, and this actually whole thing about that they being creative and we not being creative, the whole thing comes from the education itself. The education, the way we are taught. As an engineer, we are taught, and of course, it is as a profession, it is more objective. Everything that we learn is objective. Very little part of that subjectivity is involved into that. And also, we are taught in such a way that it starts with something abstract, where we are taught principles and phenomena and concept, and then we are asked to design something. And on the other hand, the architects or designers are never first taught this. And as an engineer, Bera also knows, and many engineers also knows, that we never ask this question that why are we learning this? While in case of a architecture, from the beginning, they are not taught these concepts and principles, or not abstraction. They start with the reality, and they are taught all this, and maybe in the end they may be able to abstract and work in abstraction, or even not. So what happens is the difference starts with that. Now, when you're talking about bridging the gap, meaning first and foremost is the lead will have to be taken by the architect. And if they want to take the lead, what is required is that they need to have the conceptual understanding of structure. Now, sometimes some people use the word intuitive understanding in this. Actually, I'm not really, believer of that. Intuition is fine, but at this scale of a building and other things, and the kind of material that we are using, kind of technology that we are using, your only intuition will not work. And intuition also may work, provided that intuition has been developed over a period of time after working on so many projects. Sometimes I jokingly tell that I can't have the intuition of, if I have to do appendix operation, how will I do it? I can't. I can't have that kind of intuition. I can have intuition of the thing in which I am working day in and out. But or me can intuitively say that this will work, this will not work, this form is efficient. Finally we might have to go to the computer and check whether it will work or not. But intuitively we can say, yes, it will work. So, not intuitive, but conceptual understanding of behavior of the individual members and overall form, the material, how material will behave, and how even nowadays what is becoming important is constructability of that. You can conceive something, and engineers also are nowadays, those who are there, they will say that I'll put it onto the computer and I'll design it for you. when you go to the site, the contractor will say, "No, this cannot be decided. This cannot be constructed." Or if you have to do it, I'll charge more. If you have to do it, it will cost more. So I think on one hand, I would say that lead should be taken by the architect, and the fact is why they should take the lead, because structure is only one aspect. For them, it is also the services and acoustic and whatnot. All those things are part of their foray. So they will have to, even when they are discussing with structural engineer, they will have to have also in the mind that how will the services work or will work or not. So that is definitely. The second thing that one can do is, and that partly better, that we are doing in structural design course, is that you sensitize them. If they develop some sensitivity, and even I would say they develop sometimes respect for this also. And in that case, if you see the people like Peter Rice, that where they work for Pompidou Center, he says that he was purely incidentally, he was an engineer and he worked, but he along with many architects, he created very innovative structure. He was a person who was innovative thinker. So that can happen, but he got trained like that because his first project was Sydney Opera House. So he worked there. He worked there starting from surveying, leveling to putting, and all those things. And then he got that sensitivity, and he was always working with the architects. And over a period of time, he was actually with the architects, working with the architect and creating innovative structures. So it is both ways actually. First answer is that lead should be from the architect. The second is that we as those who are in academics can, and Bhairav knows that, even for that matter, now we are also admitting the students from architecture. Those who have done the first degree in architecture, they can do the masters in CEPT. So that's the difference actually. Those kind of people, if they go to the field of structure, like one student, I still remember, he joined Mahindra Raj office. Now you can imagine this kind of people who has the background of architecture and done masters in structure. You can definitely be cognizant to this. Yes.
No, I came across this text from Robert Mellard, where he has said that, he has used the word structural art. And he has said that structural art has three components, like symbolic, which is more related to the elegance, scientific, which means efficiency, and social, which means economy and involvement of a larger part of the society.
Right.
So structure contribution in architecture, when we talk about that, these three aspects are there, like how a structure can contribute to aesthetics, how one can achieve efficiency by changing the form or changing the material or using different material together, and similarly what social impact a particular structure may have on use of labors or whatever. So apart from this, or would you like to add anything on this, that how an engineer can contribute to the aesthetics or architecture in a larger aspects? Or can you share some of your experience or your projects where you have collaborated and achieved something which is unique, or where you were satisfied that you were larger part of the project?
No, actually, this is actually that's what I was trying to show. Is one is that where structure itself becomes architecture. So where we are talking about, Nervi was an engineer, and he was trying to create not only efficient but economical structure also, because he was working for contractor, or himself was contractor. No, so he was trying to make sure that in material like concrete, the major cost is, the enabling structure. So how do you do that shuttering and repetition, etc., and how do you achieve the economy into the cost? So he was into that. Now, if you look at the other thing that I talked about, collaboration. So suppose if somebody says that efficiency is not the only concern, and we are talking about, most of the time we're talking about the structures where, the spaces, are not like what Narvi did or other Robert Myla did. You're talking about sometimes small spaces, sometimes big spaces, sometimes, different kind of spaces coming together. So there, one is that I'll come to my practice. But before that, we have now in CEPT, we are offering a studio, what we call span to space, exploring tectonics in architecture. Now, tectonics here, our simple understanding is when you put construction and structure, and they go together in such a way that it reaches the level of art, and you are not able to differentiate, okay, this is because of structure or this is because of construction. They gel so good, so together, inseparable, that it reaches the level of tectonic. Now, that is one that you can achieve. Now, in that case, when you come to the whole aspect of space and other aspect of architecture, that is in that Frampton's words, it is the tectonic, typology, and topology. So he's talking about three aspects of architecture. So in that case, we try for our students to learn this, that how do you achieve the tectonics in one material, and then we tell them that if they are sited or the terrain is such, when you put this building where something change, or even see the typology that you're talking about, meaning either it is social or even the meaning for the people, residents also. So that part we don't touch. We touch these two parts and we talk about. So we say this, that whatever the material that we are taking in the studio is not, it is just a training. It is just a skill that you develop, how to handle this material to reach the tectonic, that is understanding the flow of forces, form, construction, and achieving the space. And that space will have its own qualities based on the material and the system, and that can vary. So that is one. When we are working with the architect, we have range of people with whom we work. That we have even fresh graduate from the CEPT will come, and we are also working with the Sangat, that is Mr. Doshi's office. We are working on Nalanda project. You have also worked on some of this. So there it is a collaborative process. So they will suggest something, and if you remember that, we used to call it almost like a workshop kind of a thing. So there actually the original design, this was subject. See that I forgot to mention that for all structural engineers and architects, it is very, very important that you take your partner, that is structural engineer, in the confidence and let him be on the board from day one. That is from inception, and that is what happened from even the competition itself. We were there, and then after that, everything they got this thing, that project, and started, and then each of these structural systems, they were evolved. It was not that they had, see, whatever that was as a part of the competition entry, that remained more or less the same, but then the whole thing changed. We had introduced the compressed earth block also, so we had load bearing structures, but in some larger structures it was becoming too heavy, and also the soil was not good. So we also had some kind of a structures where the brick was as a part of that as a cladding, and somewhere it was load down. So in this process, we were continuously working with that. If something is there, sizes are there. I will give you an example that recently I shared with Raji. That at one point I still remember that the column sizes, that they had thought of 450 millimeters. And then when it came to me, to our office, we had run this ETAP software, and the sizes were not adequate enough. So we said that we need next higher size. And I said that it is 600 millimeters that is required. Then he said, okay, not 600 mm, I'll give you 850 mm if you want, but give me at a larger space. Then he had completely different, way of looking at series of columns. So this is a continuous that we talk about. Even for that matter, I'll show one image of a sun point. They wanted a large cantilever. I said that instead of a large cantilever, can you have an annular ring? So it will not be really a cantilever, but it will also give you a cantilever. So this is the continuous interaction between the architect and us that helps in evolving certain kind of decision. Even for that matter, long back, even that we had worked onto the project Bhutan. But before that, I had worked with Gurpreet Singh Ji onto his that pyramid, 23 meter by 23 meter pyramid. And that was also, evolved like this. Whole surface was analyzed, and wherever the forces were high, bending moment were high, those were trusses. Rest were simple pipes. And the interesting story was that he invited me from here. So we were going there and we designing. And that pipe, was coming to 6-inch pipe. And there was a young architect who was working there. So he said that, sir, 6-inch pipe, 150 pipe, it will look too thick. And he literally told me that what is the point of you calling from Ahmedabad and you're giving such a big size, we could do with somebody here. Then Gurpreet Singh Ji came into the picture and he said, let's make a mock-up and see. Then they made a mock-up. Even with that also, they were not conceived. They were not really, convinced about it. But then they went ahead with that. But when this whole thing was erected, that Gurpreet Singh Ji called me and he said that, Shahji, kuch dikhta hi nahi. This is very thin. It looks, because it was scale, not 23 meter. Not 20. So that is over a period of time, structural engineers can also develop that. The scale, how it will visualize. They can visualize also when it is erected. I think that in many that he had put this on poster, that gutter is some 8 meter big, but when we say 8 meter, it looks too big, but when you see the picture, you don't feel that it is 8 meters because that it is at that height. So these things, which are part of the architectural training, we as an engineer, we do not have actually. And that actually has, even in building science, we taught one studio. So there also as a part of undergraduate course and postgraduate course, there's some training which, the students can get. And your question was about us. So this is the process that we follow. And actually, that our sometimes, it is good also and it is bad also. That those who want something challenging, those who want to use some different material, those who want to use some different technology will only come to us. So then it is difficult for us, our office, but I think we are enjoying that and we get. So we have worked with stainless steel, we have worked with rammed earth, we have worked with CACB blocks, we have worked with Nimish Patel, where we worked on stone masonry also. Of course, concrete. So that is any structural engineer, will not be there who has not worked on the concrete, steel, all this material. And we have done a couple of exploration that I will be showing when we talk about that. Yes.
So I think it would not be totally inappropriate to say that aesthetics is not only architect's responsibility. Engineer's responsibility is also there. And similarly, safety is not only an engineer's responsibility. In architects, it is also a collaborative, responsibility, collective responsibility. And I think you were giving a very good example of that Japan earthquake. I think if you can share that.
Yeah. Actually, a few days back only, I was reading a book book by Kenzo Kuma. There he's talking about the lessons that he had learned from the disaster, and particularly earthquake in Japan. There he is talking about the architect's responsibility in this. And later on he talks about some disasters in US also. And surprisingly, I know I learned a lot after this the earthquake here in the disaster. I think, but it was really surprising that very few architects, learn from that earth. And I can't talk about those who have not learned, but I can talk about those who have learned. I know Professor Chaya. Professor Chaya sometimes in the studio juries can talk more about the earthquake than me. He was the first person to call me during the earthquake. That's a big story. I'll not go into that. But Kenzo Kuma's point was this, that as not only as a structure, not as an architecture, socially also one should learn from such disasters. Because wherever you know very well that the inherent strength of the structure, particularly when we are talking about earthquake-prone area, comes from the configuration. If the configuration, to start with, the configuration is wrong, we can make it thicker and we can make it more ductile and we can put more reinforcement, but it is all band-aid. That strength, comes from the form. And it is also that, somebody said that if the form is good, for seismic, and even a good, even a bad engineer can't do harm to that. It can be so strong. So more importantly, that understanding of the form, its strength, certain configurations, certain details are very, very important. And I think this is increasingly, this is going to be, more and more, either it is earthquake or other disasters. Yeah.
Okay. So coming to education, I was recently reading a book, The Blind Watchmaker by Richard Dawkins. Richard Dawkins is an evolutionary biologist, and he has said, in his initial preface that, there are two ways of teaching something or two ways of explaining something. One is in a very dispassionate way that, you tell the students or your audience the facts, and they would, based on their receptiveness, they would, capture something or miss something. The other way is, to use the art and skills of a salesman and, passionately argue in favor of something. So being yourself a bania, have you used those skills while training architects and trying to, channelize them towards, better understanding of structures, or trying to train them in a better way, or, does that dispassionate way works?
No, actually, I think that this whole thing about was a phase of my life which actually I struggled, because as you said that I was trained as an engineer, and I worked with also engineering office, Dr. Vakil's office for a few years. And that as an engineer, you don't talk about all this. And I was to teach to the students of architecture. And actually, I literally failed to do that, And then I had to struggle, and I was just trying to understand why this is not happening, why I'm not able to reach them? Why I'm not going across? So then I thought that the problem is with the English language. So I learned English from JVS Institute for 6 months. And I said that I'm now proficient in English and I can do it. So that also happened. But even after that, it was not. Then I said there is really something wrong that. And maybe that I decided that no, this is not a cup of tea for me. Let's live. Let's go. I went back. I went back to GIDC where I actually had come to school. So then the engineer said that, sorry, VR Shah, we don't have any vacant position now that is filled after you left. So whenever there's a vacancy, we'll call. But that never happened. I came back and I was wondering what to do. Then in that process, actually, I realized that their, way, that we were talking about education, their way of learning is completely different. My way of learning, my way of teaching is completely different. There's a mismatch. So as you said very rightly, as a salesman, what do? So that the person is not interested in what you want to sell. He's interested in what he wants to buy. So then in that case, I attended all history classes of Professor Muktiraj Chauhan, all history classes of Professor Chaya. I attended all environmental science classes of C.B. Shah. And then, I came across the book by Salvadori. Then I realized that, yes, how can you make this thing interesting for them? So then I learned, and then I was, as you say, that to sell my product, that got interesting. But that luckily, because I had sort of architect friends and I was doing practice also, and continuously it was, the learning, teaching, practicing in the structure. So we took it a little further, and in that also happened in the history. All this book, if you see Salvadori and other, they were talking about how to make it interesting. But later on that, Malcolm Milias and other people who came in, who talked about conceptual understanding. And then there are people who came in with the span and space, the author. He talked about how do you, bring this architecture and engineering together. So I went slowly from this to this. And that the result is that now we are also talking about this, offering a studio in architecture. As an engineer, along with the Mangesh, we are offering the studio since last 3 semesters, and I think it is getting good response. So that is the, if you want to put it that way in terms of business, yeah, I had to do a lot to sell the product. Yes.
And what about selling the idea of studio to engineering students?
Actually, that also is the interesting thing. Actually, I missed this because I was there in School of Architecture for so many years. I knew the strength of this thing, studio, where the teaching is more like doing something and meaning acting. So, and then reflecting onto that, and going from reality to the abstract, all those strengths were there, which can make you a little more creative or innovative in that sense. So I took that, I borrowed that concept from here, and I used it into structural design. And I think it worked very well there. And subsequently, it was introduced at the undergraduate course also in building science. Of course, it is in a nascent stage. It will take some time. And more importantly, I think I just talking to them also, that that is still actually the at larger level, people do not know what is studio and what is the strength. So if you want to sell that, you need to advertise this. Actually, I was just talking to somebody when Torch Steel Company, as you were saying about selling, Torch Steel Company, when they came out, the Tatas, when they came out with the Torch Steel, they never sold Torch Steel. Before the product was in the market, they sold the idea. They sold the idea, meaning what is Torch Steel and what are the real the properties of tall steel, and there's a book by which you can design and you can save some 25%, 30%. Everything was there, seminar all over India, etc. And then everybody was asking, where is the material? Then they had the material. And then you can see the tall steel is almost, synonymous of the what we call HYSD, high strength steel deformed bars. Yes.
Yeah. So, how do you see the future of both these disciplines, architecture and engineering? We were talking about Harari, and I have recently read his book, The Homo Deus. Where he's talking about the involvement of computers, architectural intelligence in our day-to-day life, and over a period of time, more and more decisions that we used to make will be made by AI. And he was giving example of how when we start using Google Map, we stop thinking about the way, and which way to take is now decided by Google Maps. Similar thing has happened to a larger extent in discipline of structure and probably even architecture. That with these softwares, a lot of decisions are being taken by softwares without mental or intellectual involvement of the designer. I think same is probably the case with architecture, with 3D softwares and visuals and all that. So probably in future, more and more decisions will be taken by the computers. So how do you think that the education should adapt to this, and what kind of changes do you see in future in both these disciplines?
So I don't know, but if you have seen that Netflix, this that comedian Kapil Sharma, his episode on I'm not done, I am not yet done. So I was wondering that when we talk about this conceptual understanding, when we talk about the experienced people, we are talking about crystallized knowledge. So I had a live example of this. The experience of this is that I had gone to in one architecture college in South where we had gone for a workshop for 6 days. So there, somebody had designed a shell in using the parametric software. He showed me everything. It was going like this, and that his director, he asked me that, Prof Shah, can you just have a look at it, and if you have any comment, you can give. So I saw it and I said that this will not stand. He said that I have done it on parametric study and this and that, and it is funicular shape, and I use Rhino software, this. I said, fine, but this will not stand. He said, why? I said, it is resting on the ground. The moment it will rest onto the ground, your computer, the simulation that you have done is different than what is reality is different, and it will collapse the moment you remove the phone. Then he told me that, why don't you talk to the person, architect who has done this parametric design? So I talked to him, and he said that I have done this, I have done that, I have done comparison this, that. Fine, fair enough. Then our workshop was over. We went, after 2 years, we went for the same workshop again, and when I asked them, I said that I'm interested in, seeing that structure, can we go and have a look at it? And that lady who was there, sir, wo to gir gaya. Immediately after the shuttering was taken out, I think, I know, I told you on that day only, because there was some, the fundamental problem with the kind of assumptions that your computer will give you, which now nobody talks about that. It is ego, garbage in, garbage out. And that the kind of simulation that you do, kind of assumption that you do about support conditions, if they're not matching your any parametric or anything will not work. So point is, let's go first that you're talking about the future with two aspects. One is that the new methods of analysis, new methods of generating the form, and the second, on the other hand, new methods of construction. Both are coming together. And few days back only, I was just watching the one structural engineer, one architect who has written a book on structures. He is working onto a robot. Not that they are going to make the robot, but the processes for how to use this robot in construction, how to use this robot in structure. So that is, if you remember, that we used to say this jokingly when we were working with, even for that matter, in my office here or before that also, that a time will come where a person will come with this requirement that I want to design this building, and then he will submit you what are the whatever the requirement of soil and this and that, and you will put it onto the computer, and on the other side you get the design. You will tell him that, okay, it's going to cost you so many lakhs and this and that, and this is the 3D view. If you like, we can press the button and your design will be done. And then he can go. But this, it looks that it is fantasy, but it is not actually. And the way the things are working, this will come very fast. And that's what you're talking about, that book Harari. Harari has written one more book after 21 lessons for 21st century also, that he's talking about all this. So in this case, my point was this only, that all what he's saying is, at the end of the day, that those who are not creating, those who are not innovative, those who are not thinking, their jobs will go. But those who are into this, so for me, I don't know, for us, our profession, if I am to say, I would say those who do not have conceptual understanding, those who do not have the understanding of behavior of the structure, will be at a great loss even after all this artificial intelligence and everything is there.
I think he has given a very good example that doctor's job will go sooner, but the nurse's job will stay larger, because they do a very wide spectrum of work. Now the two engineers here has not allowed the architect to speak much, so I think we should.
I represent the architectural fraternity, but I've been enjoying the conversation, and I think there were some questions, but I think a lot of them have been covered. Just one thing that I wanted to ask about the academics. We were talking about since you've taught architects also, and you've also taught the civil engineers, the structural engineering, and now the way I remember, we learned structures. We starting from first years, it was more of an intuition. And then slowly we moved towards some calculations, if at all, any that came towards later stage. So now, what is the difference in terms of pedagogical approach that you take while teaching architects versus the engineers? So is it that the engineers then take a step beyond and then they get into the calculations, or is there some other way in which they start from the objective front and then sort of take some steps out of the box? Is there any fundamental difference in the pedagogical approach, is what I wanted to ask you.
You want to ask me, or Vero can also answer? Vero is also
No, you please go ahead.
Okay. I think my discussion about this was that my failure to teach was also because of the fact that the way the engineers are taught. So, and at no point that I am endorsing what is happening. I'm not endorsing that. I think that should not be the case. That one should not start with all this objective aspect of it, and then finally go to something subjective and say the subjective is very limited part of it, and even sometimes they do not go there also. That I think in some architect, the book of architecture only I read somewhere that sometimes engineer know how to design the beam, but they do not know whether to provide the beam or how many beams to provide. So the question is that whole subjective aspect is equally important. Now the question is, where do you bring it? You start from there and go. And as I think I can relate to what Bhairav was asking, is that is the continuous, struggle and dilemma for us, how to teach the student. Now, and that is becoming, little more difficult when we're talking about online teaching. So our method of teaching is that, as he was saying, that we we make them curious. We make them, we take them to the level where they can grasp something, they can understand something. We ask questions, we keep on asking the question, and where they get confused. And that the level comes in where they want to know about this. And then you deliver. So that is the way, actually. So I sometimes feel that maybe a blend of it or one of them, but more of a subjective aspect of subjective aspect. Let us be a little specific about what I'm talking about, subjective aspect of it. Then I still remember that when we started this postgraduate course in structural design, there in the earlier years, we had full freedom, and there was one whole studio, where it was talking about only conceptual understanding of large structures, no calculations, nothing. So there they can think of, the structures like, cooling towers or space frame structures, or no design done. Now, what are the kinds of load? What will be the kind of framework? What are the construction requirements? They will learn that only. And I still remember that one of the students who had taken this, that the Swati building, that you see the space frame, were designed by that first year batch student. Actually, he actually then from there, he went to New Zealand, he did his PhD, and he's there. So these whole thing, I have number of such examples. How do you really make them, the most important thing is that when we read Peter Rice's book, that engineers imagine. So we need to go into that direction of imagination, thinking, innovation, creativity. How do you go into that? One is that you study from others, and also that you are challenged in the education itself to innovate something, to create something different. Maybe it is building the entire thing, or even thinking. And actually, I'll give one example of this. I can show it on the PPT, but this will disrupt the whole thing. So I'll just narrate it here. That not only here in engineering, but in architecture also, we have now started teaching construction and structure together. So that is integrating not just structure and architectural design, but structure and construction, and then obviously coming to architectural design. So in that case, we had worked out one assignment where they will have to designing the giant from Marvel's character. They see these movies and all. So they designed the giant, some 60, 70 meter high, and and what are the strengths and weaknesses of that giant, how it works, etc. And then they will have to design a throne for that giant. So that big, and then we'll tell them that now that giant has gone, this throne is now used by the human beings as a building. So how do you convert that into a building? The kind of material, kind of system, spaces, how will you create? So this whole thing, starts with imagining something. And, we had actually at some point of time, students were lost. They were asking, we are here to learn this structure, construction, structure-based construction. But at the end, they were happy. So they started with, complete. So I was talking about this imagination and other things. How do we bring it into the engineering education? And partly, I think, President Dean Anil Shah, and with the studio, I think they are trying to bring it. That instead of just starting with simple calculations or 1, 2, 3, 4, 5, 6 courses, you have different kinds of studios where you instead of just doing just calculations, you'll be designing. When you start designing, you need to imagine. So designing and making sure that it works. If it's not working, you redesign and go on. I think this is what the engineering education, and I think that there are further challenges actually, that what Bhairav was talking about, these Harari's examples and other things, is I just referring to that person from Harvard who is working. Bhairav, it was surprising. He was talking about a robot and other thing, that he was saying that we are getting people from India and China and other. So robots can do the same work of labor and other things. I was wondering that a time may come that Indian companies may collaborate. They will get the robot here in India and they will do the construction with that robots if your labor is too expensive here. That I think slowly we are feeling that, and maybe that our laborer will have to go home and play on smart phone, and maybe that our government will give them minimum monthly payment to survive. So I was reminded at this time. I was reminded of Mr. Tambe, who actually founded this School of Building Science and Technology. He was talking about this, that how do you innovate? How do you find those technologies which are used into the big projects for the smaller things? So like all these robotics and other things, that I had to deliver a lecture in one construction course. So that how do you make those things workable for normal construction? That is not that like recently in medical science also, many places I had this experience. For my wife's, one of the teeth for the cap, they scanned the whole thing, whole mouth, and then it went to the cam and teeth. You have everything fitted and it comes. And one of my friend had also this robotic surgery, that was performed. So these things either coming in medical, so it will come into civil engineering, in the construction also. But right now, nobody's thinking at a lower level. Everybody's thinking about BIM, software and everything, like Larsen and Toubro doing some 3D printing and other things. But I think that can happen at lower level. Like maybe that as we were talking about this, can I have some, things where like complicated part of my buildings are done into 3D. Rest is, done manually or with some brick or concrete or stone. So these things are bound to come. But at this level, nobody is, giving some thought to that. Yeah. Fine, yes. I hope I answered, not fully, but partly to the question that you asked. Yes.
No, and this theme has actually occurred continuously. That when we started, you said that on one hand, we have people like Nervi and Robert Maillard and people who have taken the art structure to the level of an art. Okay.
Yes.
But on the other hand, when I talk about a very simple, let's say a building, something like what we see, may look like a mundane building, let's say an apartment building, even in that sense. Now, even in that sense, how one brings in efficiency, how one wisely selects the structural system, what is the grid, how does one select the placing of the shear walls and stuff like that. And there in itself also, I think if the architect is sensitive about the way the building is going to behave under the earthquake and the lateral loads, can, make a lot of difference. And you were also mentioning in between that, and I strongly believe that structural engineer, or from day one, if he is involved in the design process, a lot of difference can be made. And you shared the experience of the Nalanda and how by changing the column size and the grid, and finally you sort of find an optimized solution that not only helps the structural grid solve, but also architecturally, it is able to give you a better experience. So I think the fundamental takeaway from this particular talk I see is that, it is a blurring of the boundaries here, that the architect needs to come out of his shoes of being an architect and think from the structural engineer's point of view. And at the same time, the structural engineer needs to come out of his shoes and think more like a designer when they sit on a table to sort of, kind of negotiate or sort of come out or collaborate. So that sort of in between realm is perhaps the best place to be, is what I have realized, and that is where I think the best efforts and the best projects also come out. And it was visible, like in that Mahendra Raj project that you mentioned, the Convinde was willing to have a column inside that hall. But then Mahendra Raj comes and says, okay, we can do it without, the columns. And that is where the synergies are happening and the best products can sort of come up. I think that is the fundamental takeaway, that I see it. And I think the discussion is we can continue discussing like this further as long as we can. But I think we can, if Bhairav is okay, then we can sort of conclude it here. And I would like to thank both of you. It was, let me tell you that both of us actually are your students in at some or the other. I was your student in the bachelor's, and Bhairav has been your student in the master's program at CEPT. And it was pleasure. It was pleasure having you and sharing your experience. I'm really thankful to you, sir, that you gave us your time and shared your valuable experiences. I wish we could continue like this and talk more. And so hopefully we'll be able to continue this discussion when we meet in person at CEPT. So thank you so much for giving us your time.
No, it is always a pleasure to have this kind of discussion, and in a way, both of you are known to me. So Bhairav, not only that is he actually, in true sense, I never taught him. I was the head of that postgraduate course, and I was in charge of that thesis that he was doing. But otherwise, I never taught him. But I think not only that, but later on, I think the way he went to VMS and that we were together in Sikkim, and then he started his own practice. He was working on some of our projects also. We worked on this project in Bhutan also, and I think we also talk about this whole aspect of the structure and architecture, because his practice is also focused more onto the works of the architects. But this always is actually I think that the whole format, I think we have changed. I don't know, you can ask for some response from the those who have watched this, that is it good to have just the presentation and bombarding of PPTs, or is it good to have some simple talks like this? Because I see many videos of this, what you was talking about, Harari and other things. They're talking with different people, and this is not so structured, at the same time not completely off. But talking about two professions, their experiences, sharing their experiences is always the good part of being into the profession and having experience. Yep. Great. I think nice. Sure. See you all.
And Bhairav, I would like to thank you also. I mean, it has been a wonderful journey. We started discussing this, and we had meetings and phone calls, and in fact, the whole process has been enjoyable. And thank you so much from the ArchiDiaries team to you.
Thank you for inviting. I really enjoyed this conversation. I think the dialogue should continue to happen between the different disciplines. So I think I really enjoyed. Thank you for inviting.
Right. Yeah. Same here.
Just like to conclude by thanking the people who have joined on various platforms. and hope to see you again on the next Tuesday with, I think, the 4th interview in this series. So thank you so much.
Yeah. Okay. Bye.
Bye.